You are almost certainly mistaken about what time really is, even though it feels familiar to you. You wake up in the morning, glance at a clock, remember yesterday, and imagine tomorrow. Because these experiences feel consistent, you assume they are reliable. You believe time is something obvious, something you understand intuitively, but that confidence is an illusion created by your own biology. None of the things you associate with time are actually time itself. Aging, memory, anticipation, and clocks are not time. They are signals and tools. They are interpretations produced by your brain to help you function in the world. They feel convincing because they evolved to be convincing, not because they are accurate representations of reality. Most people imagine time as a river. It is one of the most persistent metaphors in human thought. The past lies behind you, the future stretches ahead, and the present is the point where you float along with the current. This image feels natural because it matches how your experiences unfold. You remember what has already happened. You do not remember what has not happened yet. So it feels as if something is carrying you forward. But the moment you examine this idea carefully, it collapses. If time is a river, then it must flow at some speed. And the only answer anyone ever gives is that time flows at 1 second per second. That statement sounds reasonable until you notice that it explains nothing. It is a circular definition. Saying that time moves 1 second per second is like saying that a meter stick is 1 meter long. It adds no information about the structure of reality. When metaphors fail, what remains is something much stranger and far less comforting. Time does not flow. It does not move. It does not push you forward through existence. And the reason this feels wrong is not because the idea is wrong, but because your intuition was never built to understand the universe at this level. The confusion starts inside your own head. You assume that you have an internal clock, a reliable mechanism that keeps track of duration, but this assumption is false. Your brain does not measure time the way a clock does. It assembles an experience that feels like time. Consider a simple mental experiment. Sit quietly and try to count to 60 without looking at a clock. Pay attention to how you are doing the counting. Some people hear an internal voice repeating the numbers. 1, 2, 3. For them, counting is a verbal process. If they are interrupted or asked to speak out loud, the count immediately falls apart. Other people experience something completely different. They do not hear numbers at all. Instead, they see a sequence, a mental scale, a line of marks sliding forward. These people can often continue counting even while doing something else, like reading or sorting objects. Their counting mechanism uses different mental circuits. Two people perform the same task. Both believe they are tracking time accurately, yet the internal machinery they rely on is entirely different. This tells us something important. What you experience as the passage of time is not universal. It varies from person to person. It depends on attention, perception, and neural shortcuts. Your sense of time is not a feature of the universe. It is a feature of your brain. This is why physics cannot rely on intuition. When physicists study time, they deliberately ignore how it feels. Feelings are unreliable. Instead, physics focuses on operations. What can be measured? What can be compared? What remains consistent across observers? So physics does not ask what time feels like or what its true essence might be. Physics asks a much simpler and more precise question. How do we measure time? The answer is surprisingly modest. Time is a way of ordering events. It is a system for labeling change. Imagine laying objects out in a row. You can say one object comes before another, and another comes after. Nothing needs to move for this order to exist. The order is a relationship, not a process. Time works the same way. Events are ordered relative to one another. When you say that something happened earlier or later, you are describing a position in an ordering scheme, not a motion through an invisible substance. This is where everyday thinking goes wrong. People imagine time as a container, a background that exists even if nothing happens. They imagine that if the universe were empty, time would still tick away somewhere in the background. Tick, tick, tick. This idea comes from an older way of thinking about physics, and it does not survive closer examination. Time is not a stage on which the universe performs. Time is a measure of change within the universe. If nothing changes, time has no meaning. You cannot define a second without referring to some physical process. A pendulum swinging, a crystal vibrating, an atom oscillating. Without change, there is nothing to count. Time does not exist independently of matter and energy. It is not separate from the universe. It is a property of how things behave. This realization leads to another common misunderstanding. People speak as if time itself causes events. Time makes people age. Time ruins buildings. Time spoils food. But time does none of these things. Chemical reactions cause aging. Microorganisms spoil food. Physical processes break structures down. Time is simply the framework we use to describe how fast these processes occur. It is a ruler, not a force. Saying that time causes something is like saying that distance causes motion. Distance does not push objects. It only describes relationships between positions. Time plays the same role for change. Once you let go of the idea that time is an active agent, the picture becomes more precise and more unsettling at the same time. Time is not a thing acting on the universe. It is a description of how the universe changes. And this is only the beginning of the problem. Once you accept that time is not an active force, another assumption quietly falls apart. Most people believe time is rigid, that a second is a second everywhere, for everyone, under all conditions. This belief feels so natural that questioning it almost sounds absurd. If two clocks are built correctly, why wouldn't they tick in perfect unison no matter where they are? For a long time, physicists believed exactly that. They assumed time was absolute, a universal rhythm beating evenly throughout the cosmos. A clock on Earth and a clock on a distant planet were thought to march forward together, synchronized forever. That assumption turned out to be wrong. Time is not rigid. It is flexible. The rate at which time passes depends on where you are and how you move. This is not a technical flaw in clocks or a problem with measurement. It is a fundamental feature of reality itself. Clocks do not malfunction when they tick at different rates. They are faithfully recording how time behaves under different conditions. To understand why this happens, you need to abandon the idea that motion through space and motion through time are separate things. In reality, they are deeply connected. You are always moving through the universe at a constant overall rate. What changes is how that motion is divided. Imagine your motion as a fixed budget. When you are standing still, all of that motion is devoted to moving through time. You age at the maximum possible rate. But the moment you start moving through space, some of that motion is redirected. As more motion goes into space, less remains for time. The result is unavoidable. Your clock slows down. This is not because the clock is struggling. It is not because time is resisting motion. It is simply geometry, a change in direction through space-time. At everyday speeds, this effect is tiny. You do not feel your watch slowing down when you walk across a room or run for a bus. The difference is far too small for your senses to detect. But it is real, and when speeds become extreme, the effect becomes impossible to ignore. Satellites orbiting Earth move fast enough that their clocks tick at a different rate than clocks on the ground. If engineers did not correct for this difference, navigation systems would drift and fail. The math of flexible time is not abstract philosophy. It is used every day. There is an even stranger consequence hidden inside this idea. If motion through space reduces motion through time, then there is a limit, a maximum possible speed. And at that limit, something extraordinary happens. At the speed of light, all motion is directed through space. There is nothing left for time. From the perspective of light itself, time does not pass. Emission and absorption occur at the same instant. The universe, from that point of view, is frozen. This is deeply counterintuitive. It clashes violently with everyday experience. But everyday experience is built for survival, not for understanding the structure of reality. Now, consider another illusion layered on top of all of this, the feeling that time has a direction, that it moves from past to future, that the past is fixed while the future remains open. This sensation feels obvious. You remember yesterday. You do not remember tomorrow. But this asymmetry is not caused by time itself. It is caused by probability. The laws of physics, at their deepest level, are mostly indifferent to direction. Many of them work just as well forward as backward. If you film a planet orbiting a star and play the video in reverse, nothing looks wrong. The motion still obeys the same rules. But if you film an egg falling and shattering on the floor, the reversed footage immediately looks fake. Shards do not leap upward, reassemble, and seal themselves back into a shell. The difference has nothing to do with time. It has to do with likelihood. There are countless ways for an egg to be broken. There is only one way for it to be whole. As systems interact, they naturally drift from states with few possible arrangements to states with many possible arrangements. Order gives way to disorder. This tendency has a name: entropy. Entropy increases because disorder is statistically favored. It is easier for systems to fall apart than to assemble themselves into precise configurations. This statistical drift creates the arrow you experience as time. Your brain is not sensing time flowing. It is sensing change becoming irreversible. It is detecting the growth of disorder and labeling that direction as the future. If the universe were perfectly ordered and unchanging, there would be no arrow, no memory, no sense of before and after. The past and future would be indistinguishable. This brings us to another deeply unsettling idea: the notion of a universal present moment, a cosmic now that applies everywhere at once. That idea feels obvious. Right now, you assume something is happening on a distant planet. You imagine a shared present stretching across the universe like a blanket. But physics does not support this picture. What counts as now depends on motion. Two observers moving differently will disagree about which events are happening at the same time. Both measurements are correct. There is no master reference frame that settles the disagreement. This means there is no universal present, no single moment slicing across the cosmos. Reality is better described as a four-dimensional structure, a vast collection of events arranged in space-time. Past, present, and future are not separate realms that come into existence one after another. They are all part of the structure. Nothing flows, nothing appears, nothing disappears. The sense of movement comes from your consciousness tracing a path through this structure, the way a scanner moves across a page. The page itself does not move. The information is already there. This idea often triggers an immediate objection. If the future already exists, what happens to choice, to freedom, to responsibility? But this question mixes levels of description. Physics does not claim that the future is known or predictable in practice. It only describes how events are arranged. Complex systems still evolve. Patterns still unfold. Causes still lead to effects. You are not a passenger watching time go by. You are part of the pattern. A process unfolding according to physical rules. The fact that the structure exists does not remove the experience of decision-making within it. At this point, many people feel a kind of resistance, a sense that something deeply familiar is being taken away. That is not an accident. You evolved to think in terms of flowing time because it was useful. It helped you anticipate danger, plan actions, and coordinate with others. You did not evolve to understand space-time geometry. When physics contradicts intuition, it feels disturbing because it forces you to abandon metaphors that once worked. But discomfort is not a sign of error. It is a sign that you are learning something your instincts were never designed to handle. And we are still not finished. There is another layer to this problem that quietly undermines everything you think you know about time. And it has nothing to do with clocks or equations. It has to do with how your brain builds meaning. The way you store information shapes the way reality appears to you. And this becomes painfully obvious when you look at how different people imagine the same concept. Think again about the simple act of counting seconds. Some people hear numbers spoken internally. Others see symbols or spatial patterns. Both approaches arrive at the same numerical result, but the internal experience is completely different. This difference is not trivial. It reveals how fragile common sense really is. When two people talk about time, they believe they are discussing the same thing. They nod, agree, and move on. But internally, they may be running entirely different mental models. One imagines a line stretching forward. Another imagines a ticking mechanism. Another imagines a voice counting beats. The words match, but the meanings do not. This matters because physics does not speak the language of intuition. It speaks the language of structure. When physicists talk about time as a dimension, they are not describing a feeling. They are describing geometry, and geometry does not care how it feels to be human. This mismatch is why ideas like relativity feel so wrong at first. You are trying to translate a high-level description of reality into a low-level biological interface. It is like trying to understand a satellite image by listening to a heartbeat. The tools simply do not match the task. Your brain evolved to notice patterns that mattered for survival. When the sun rises, when food spoils, when danger approaches. These patterns were compressed into intuitive shortcuts. Time, as you experience it, is one of those shortcuts. It works well enough to get you through daily life, but it was never meant to reveal the architecture of the universe. This becomes especially clear when you think about the concept of simultaneity. You assume that events either happen at the same time or they do not. It feels binary, obvious. But simultaneity is not absolute. It depends on motion. Imagine two distant events occurring far apart in space. One observer measures them as simultaneous. Another observer, moving relative to the first, measures one as happening before the other. Both observers are correct. There is no deeper fact that resolves the disagreement. This is not a flaw in perception. It is not a limitation of instruments. It is how space-time is structured. The universe does not come with a built-in slicing into moments. That slicing is something observers impose. Once you accept this, the idea of a universal present dissolves completely. There is no single now stretching across the cosmos. What you call the present is a local concept, defined by your state of motion and your position in space-time. This leads naturally to the block view of reality. Instead of imagining time as something that flows, imagine the universe as a complete four-dimensional structure. Every event that ever happens is part of that structure. Births, supernovae, thoughts, deaths, all exist as coordinates. Nothing moves within the block. Nothing comes into existence or fades away. The feeling of change comes from how conscious systems traverse the structure, not from the structure itself. This is deeply uncomfortable because it clashes with how memory works. You remember the past. You anticipate the future. It feels as though the past is gone and the future does not yet exist. But memory is not a reliable guide to ontology. Memory is a physical process that encodes certain states and not others. Your memories point in one direction because entropy points in one direction. You remember? States of lower disorder because records can only form when systems are not yet maximally scrambled. The future lacks memories not because it does not exist, but because the physical conditions required to store those memories have not yet occurred. This distinction is subtle but crucial. The absence of memory does not imply the absence of reality. It only reflects the limitations of how information is stored. Now consider the beginning of the universe. If time is a measure of change within the universe, what happens when you trace that change backward as far as possible? You reach a state where the universe becomes smaller, hotter, denser. Eventually, the concepts you rely on begin to break down. At some point, the physical processes that define clocks and rulers cease to exist in any meaningful way. At that boundary, asking what happened before becomes questionable. The question assumes a temporal framework that may not apply. This is similar to asking what lies north of the North Pole. The question is grammatically valid, but geometrically meaningless. North is a direction defined on the surface. At the pole, the direction simply ends. If time emerges from change, then the beginning of the universe may also be the beginning of time. Not a moment within time, but the point at which temporal ordering itself becomes meaningful. This idea clashes with a deep psychological need. Humans crave stories. We want origins. We want a sequence that stretches endlessly backward. Accepting that time itself may have a starting boundary feels incomplete, almost offensive to intuition. But the universe is not obligated to satisfy narrative expectations. It operates according to structure, not storytelling. This tension between intuition and physics appears again and again. Each time we develop a new theory, we are forced to abandon metaphors we once trusted. Classical mechanics worked well for everyday motion. Relativity replaced it with a deeper framework. Quantum theory replaced certainty with probability. Each upgrade feels wrong at first. It requires discarding mental models that once felt obvious. The process is uncomfortable because it demands that you rewire how you think. This does not mean intuition is useless. It means intuition is limited. It is optimized for survival, not for truth. Physics extends intuition by replacing metaphor with mathematics, imagery with structure, and feeling with measurement. When you stop insisting that time must behave the way it feels, patterns begin to make sense. The slowing of clocks, the relativity of simultaneity, the absence of a universal present. These are not paradoxes, they are consequences of a deeper order. And yet, despite all of this, time still works for you. You still meet friends at scheduled moments. You still cook meals and plan trips. The strange geometry of space-time remains hidden beneath layers of approximation. You do not need to understand relativity to live your life, but understanding it changes how you see existence. It replaces a comforting illusion with a more accurate map. And that map, though unsettling, is far richer than the story it replaces. There is one final mistake that almost everyone makes when thinking about time, and it is the most subtle of all. We assume that because time is strange, flexible, and relative, it must somehow be unreal. That conclusion is tempting, but it goes too far. Time is not fake. What is fake is the story we tell ourselves about it. When physicists say that time does not flow, they are not denying experience. They are pointing out a mismatch between structure and sensation. The universe is not organized the way your intuition suggests, but your intuition still functions perfectly well at the scale of daily life. Both can be true at the same time. Think about how you use a map. A map does not move. Cities do not slide across the paper. And yet, when you travel, it feels like motion. The movement is real, but it is not happening on the map. It is happening relative to the map. Time works in a similar way. The structure is static. The experience is dynamic. This distinction becomes important when people worry that physics somehow drains life of meaning. If the future exists, they say, then nothing matters. But meaning was never provided by the flow of time. Meaning comes from relationships, from processes, from patterns unfolding within the structure. A book does not lose its meaning because all its pages exist at once. Your life is not meaningless because its events are part of a larger structure. It is meaningful because of how those events relate to one another. Choice, effort, and responsibility still operate within the pattern. The existence of the pattern does not erase the experience of living through it. Another source of confusion comes from language. We talk about time using verbs that imply agency. Time passes, time heals, time destroys. These phrases are convenient shortcuts, but they smuggle in assumptions that do not belong there. Time does not act. Processes act. Time only labels their order. Once you see this, many everyday puzzles dissolve. You stop asking what time will do to you and start asking what processes are changing and why. Aging is not time attacking the body. It is chemistry unfolding. Decay is not time winning a battle. It is entropy doing what probability favors. This way of thinking also clarifies why the universe appears stable despite the strange behavior of time at fundamental levels. The flexibility of time becomes noticeable only under extreme conditions. High speeds, strong gravity, vast distances. In ordinary life, the differences are so small that they blend into a single, shared approximation. That approximation is what you call common sense. Common sense is not wrong. It is incomplete. It is a set of simplified rules that work well enough within a narrow range. Problems arise only when you mistake those rules for universal truths. Physics does not invalidate common sense. It explains its limits. This brings us back to the strange differences in how people imagine time internally. The voice counting numbers, the visual tape sliding forward. These differences show that even basic concepts are mediated by private translation schemes. When you hear the word minute, you convert it into imagery that makes sense to you. Someone else converts it differently. The fact that you arrive at the same conclusions most of the time hides how different the internal machinery really is. But when concepts become abstract, those differences matter. They determine which ideas feel intuitive and which feel impossible. This is why learning physics often feels like unlearning. You are not just adding facts. You are replacing internal pictures. You are discarding metaphors that once worked and adopting structures that feel unfamiliar. The discomfort you feel is not confusion. It is recalibration. Every major advance in physics has required this kind of mental shift. The Earth moving around the Sun. Space and time forming a single structure. Particles behaving like probabilities. None of these ideas felt natural when they were introduced. They felt wrong because they conflicted with deeply ingrained intuitions. Yet they worked. They predicted outcomes correctly. They explained patterns that intuition could not. Over time, they reshaped how reality is understood. The same process is happening with time. The river metaphor is being replaced by geometry. Flow is being replaced by structure. This does not make the universe cold or mechanical. If anything, it makes it more astonishing. The fact that such a counterintuitive structure produces a world rich enough to support life, memory, curiosity, and self-reflection is extraordinary. You are a small, temporary pattern inside a vast arrangement of events. Your thoughts, choices, and experiences are part of that pattern. They are not diminished by the structure. They are defined by it. Time, in the end, is not an enemy or a force acting upon you. It is not something you are running out of. It is the framework within which change is organized. It is the condition that prevents everything from happening at once. When you look at a clock, you are not seeing time itself. You are seeing a device designed to coordinate human activity. It reassures you because it compresses a complex structure into a simple signal. That simplicity is useful, but it is not the whole truth. The deeper truth is stranger and quieter. Time bends. Time depends on motion. Time has no universal present. Time may have had a beginning. And yet, it still works well enough for you to live, plan, and care. If this understanding leaves you feeling unsettled, that is not a failure. In science, discomfort is often the sign that a comfortable illusion has been replaced by a more accurate description. Confusion is not the end of understanding. It is the threshold. You do not need to master equations or visualize four-dimensional geometry to appreciate this shift. You only need to let go of the idea that time must behave the way it feels. The universe does not owe you intuitive explanations, and yet, remarkably, it allows you to understand it anyway. You are a biological system built from stardust, using imperfect tools to glimpse a structure far larger than yourself. The fact that you can do this at all is not obvious. It is astonishing. Time is not what you thought it was. It is deeper. It is stranger. And understanding that is one of the quiet triumphs of human thought.